However, because lunge controls limit the pressure compensation which the valve can produce, lunge control should be used only where load pressure remains relatively constant. One other common method of controlling the speed of actuators is to bleed off a portion of the flow before it gets to the actuator. This can be done by using a flow control valve to bypass a portion of the system's total flow back to tank. For example, if a pump develops a flow rate of 100 GPM, but the actuator requires only 90 GPM, we could use a large flow control valve capable of reducing the 100 GPM flow to 90 GPM. Or we can install a smaller, less expensive flow control valve to handle just 10 GPM in what is known as a bleed-off circuit. This smaller valve controls the flow to tank rather than flow to an actuator. A disadvantage of a bleed-off circuit is that it does not offer precise flow regulation to an actuator. Since the downstream side of the valve ports to tank rather than to the actuator, the valve cannot compensate for changes in load pressure at the actuator. In all the flow control circuits we've seen so far, the flow control valve has been on the inlet side of the actuator. These are called meter-in circuits. This meter-in technique works well as long as a load is being moved in one direction and there is no need to control the velocity of the return stroke. A meter-out circuit can be used to provide that control. In a meter-out circuit, the valve operates the same way it does in a meter-in circuit, but the valve itself is placed on the outlet side of the actuator. As a result, the valve controls the flow out of the actuator rather than into the actuator. In this lesson, we have shown how flow control valves are used to vary the velocity of actuators by controlling orifice size and by adapting to changes in fluid pressure and temperature. In the next lesson, we'll look at directional control valves.